Hello friends, this is Gangadhar from the YouTube channel Maths Ganga. Now in this video, I took a chance to discuss the solutions for the pre-RMO paper which was held the last Sunday in this year 2018. See, the first question of the paper is, a book is published in 3 volumes, the pages being numbered from 1 onwards. The page numbers are continued from the first volume to the second volume to the third. The number of pages in the second volume is 50 more than that in the first volume. And the number of pages in the third volume is 1.5 times that in the second volume. Okay. The sum of the page numbers on the first pages of the 3 volumes is 1709. And if n is the last page number, what is the largest prime factor of n? See, usually we face different types of problems related to the page numbers in different competitions, the previous competitions. And this was a different question, but if we rate it comes under the average type of question. Okay. Now, let us see if a book is published in 3 volumes. Totally, there are 3 volumes of the book. Volume 1, Volume 2 and Volume 3. Okay. And they mentioned that the page numbers are continued from the first volume to the second volume and second volume to the third volume. The page numbers are continuing. Okay. See, the number of pages in the second volume is 50 more than the first volume. If you let the number of pages in the first volume as some p, then the number of pages in the second volume is 50 more than in the first volume. So the number of pages are p plus 50. Whereas in the third volume, 1.5 times means 3/2 times of the number of pages of the second volume. 3/2 times of the p plus 50. These are the 3 books, and this p plus 50 and 3/2 times of p plus 50 are the number of pages in these books. Now, in the first volume there are p pages. So the page numbers are from 1 to p. So the first page of the first book is page number 1 and the last page of the first book is page number p. And the page numbers are continuing. For the second book, the first page number is p plus 1. Since the first page number is p plus 1, okay, then what is the last page number of this book? What is the last page number of this book means? The first page number is p plus 1. P plus 1. Since it has p plus 50 pages, the last page number of the book is this p plus 50. So the last page number of the second book is 2p plus 50. The first page number of the second book is p plus 1. The last page number is 2p plus 50. Whereas the page numbers are continuing for the third book also. Sorry. And for the third book, the first page number is 2p plus 51. Next page of the next page for the last page of the second book. So 2p plus 51. The last page of this third book is this 2p plus 50 plus this value. Okay. So the last page is what? 2p plus 50 plus 3/2 of p plus 75. 3/2 times of 50. So the number of pages in the books are p plus 50, 3/2 of p plus 50. And the pages are 1 to p in the first book, p plus 1 to 2 plus 50 in the second book, 2p plus 51 to that page in the last book. And they mentioned that the sum of the page numbers in the first pages of the 3 volumes is 1709. So if you add these first pages, your value is given as 1709. And if you add, what will happen? 2p plus p is 3p, 51 plus 2, 52 plus 3 is 53. So this 1709 is equals to 3p plus 53. So 3p plus 53 is 1709. And if you calculate, you will get the value of p as 552. The value of p as 552. So the number of pages in the first book is 552 and continues for the second and third books. Now the question is, if n is the last page number, what is the last page number? This is the last page number for all the 3 books. So our last page number, they mentioned it as n. If n is the last page number, what is the largest prime factor of n? We need to calculate n and we need to find out the largest prime factor for this n. Already we have that P is equals to 552. If you replace this P 552 in this expression, you will get the last page number as 2057. Just you calculate it by replacing 552 in the place of P. See, you get the last page numbers as 2057, and we need to calculate the largest prime factor of 2057. So if you prime factorize that 2057, okay, you will get the largest prime factor for 2057 is 17, and your answer for the question is 17. Okay, there is the first problem of the pre-RMO 2018, right? So just go through it. So there are three volumes, and the number of pages are mentioned with these relations, and the page numbers are continuing. So since the first book contains the page numbers from 1 to P, second book starts with P plus 1 and ends with 2P plus 15. Whereas the third book starts with 2P plus 51 and ends with this page number. They mentioned the sum of these three values as 1709. From there we calculated the value of P as 552. If we replace this value of P in the last page number, you will get the last page number as 2057. They ask us to calculate the largest prime factor of that n, and it is 17. There is the first problem, right? Now, let us see the second problem of the pre-RMO 2018. As we are very familiar that these Olympiad examinations are more concentrating on the number theory as well as with geometry. So the first question is regarded as related to number theory, whereas the second question is related to the geometry. For the second problem, they mentioned that in a quadrilateral ABCD, it is given that AB is equals to AD is equals to 13, and BC is equals to CD is equals to 20, whereas BD is equals to 24. We have a quadrilateral with these dimensions, with these measurements. If R is the radius of the circle inscribed in the quadrilateral, what is the integer closest to R and 800? So we need to calculate the integer closest to R and 800. So basically we have a quadrilateral. How the quadrilateral is formed? And AB, AD is 13, 13, BC, CD is 20, 20, and BD is 24, which is nothing but most probably, usually it is a kite, okay? I think so. Since these, if you have a quadrilateral like this, okay, since these two are same, 13 and 13. If you name it as like A, B, C, D, in the problem they mentioned that AB is 13, AD is 13, whereas BC is 20 and CD is 20, and also they mentioned that this BD is equals to 24. And when one circle is inscribed in it, we need to calculate the radius, okay, and the integer nearest to the radius value. So this is the diagram, and this length is given as 24, and in this kite shaped quadrilateral, okay, if you insert a circle, okay, and we are going to calculate the radius of this circle. Let it as R, let it as R, this is also as R, and this is also as R, okay. Now coming to this, here this is 13, 13. Since it's an isosceles triangle, upper isosceles triangle, lower isosceles triangle, if you join AC, okay, in the kite the diagonals bisect bisect at right angles and bisect each other. Since they mentioned it as 24, 12 and 12, and this is 13, this is 12, and this is 5 as Pythagorean triplet. And since this is 20 and this is 12, so this is 4 3s, this is 4 5s, so surely this is 4 4s, again Pythagorean triplet. And if you calculate the area of the upper triangle as well as the area of the lower triangle, for the upper triangle the area is how much? The base is 24, whereas the height is 5, so the area is half 24 into 5, area of the upper isosceles triangle. Whereas coming for the lower isosceles triangle, the area is mentioned as half 24 into 16. And if you calculate, this is 2 12s, whereas this is also 2 12s, 12 into 5 plus 16 is 21. If you calculate, 12 ones is 2, 12 twos is 24, and 262 is the area of the quadrilateral. Okay, 12 ones is 12, 1 2, 12 twos is 24 plus 1, 252 is the area of the quadrilateral. Now coming to this case, since a circle is inscribed in it, since we are going to calculate the radius, see how can we relate this area with the radius. Okay, so I am redrawing the diagram, right? See, since the kite is like this, for our convenience, if you took it in that manner, an isosceles circle is inscribed in it. like this. If this is the center, this is radius r. Okay, this side is, we know it as 13. This is also 13. This is 20 and this is 20. See, if you look carefully, if you join the vertices like AB with the center, this is also a triangle. For this triangle, base is 13 whereas height is r. So if you calculate area of this triangle, the area is half base into height, which is nothing but half into 13 into r. This is the area of this triangle. This side is also have the same measurement as 13. So if you join this D with this center, okay, this is also radius. We know that radius line is perpendicular to the tangent line. All these sides acts like tangents for the circle. So this radius line is perpendicular. Again, this base is 13 and this radius is r. And if you calculate the area, again it is half 13r. So basically, area of this is half 13r and that is half 13r. Two triangles having the area half 13r. Plus, in the same manner, if you join the center with C, and this is also radius, whereas this is also radius. So if you apply half base into r for this triangle and for the triangle, two triangles have same area as half 20 into r. And if you simplify, 2 into 1 by 2 get cancelled, 13r and 20r, which is nothing but 33r. So calculating the area of the given quadrilateral in terms of radius is 13r, and in terms of the using the side length as 252, if you equalize these two, you will get the value of radius, which is equal to 18. Okay, so then the step value of the integer closest to that r is 8, and your answer is 8. Okay, r is equals to 252 by 33, and on simplification you get the radius as 8, and that 8 is your answer. Okay, so this is the second problem of the pre-RMO 2018. Here we calculated the area of the given quadrilateral in two ways. In one way, we used the side lengths, and in the other way, we used the radius of the incircle. Okay, just look here, and the radius value, and your answer is 8 for this question. Okay, there is the second problem, right? Then coming to the third problem. See, if you look there, for the third problem, consider a 6-digit number of the form ABCCBA. We have a 6-digit number of the form ABCCBA, where B is an odd number. So also they mentioned that B is odd. Okay, fine. Determine the number of all such 6-digit numbers that are divisible by 7. See, we need to replace these ABC with different digits, so we get different types of numbers. See, we have to count the numbers which are divisible by 7, which are in this format where B is odd. So count the number of numbers which are divisible by 7. See, since this number is divisible by 7 as the problem, the divisibility rule for 7 is difference between the first three digits and the last 3 digits of a 6-digit number is divisible by 7. If you need, already I discussed the proof for this one in this previous videos of divisibility rules. Okay, so if you need the proof for this, just go through the video on the divisibility rules. Okay, right. So difference between the first 3 digits and the last 3 digits of a 6-digit number is divisible by 7. If the given number is divisible by 7, so ABC minus CBA is divisible by 7. The difference. See, what is ABC? This ABC is a 3-digit number which is whose expanded form is 100A plus 10B plus C. Minus CBA is a 3-digit number whose expanded form is 100C plus 10B plus A. This is divisible by 7. So this difference is 7 multiple. So if you simplify it, 100A minus A is 99A, 10B and 10B get cancelled, C minus 100C, 99C. If you common out 99, we have that A minus C is equals to 7 multiple. Okay, see, if you look, 99 is a combination of 3, 2, 5 like that, 3 and 11, 9 into 11, so it's a combination of 3 and 11. No 7 is included in this 99. So since this number is a multiple of 7, surely this A minus C is a multiple of 7. See, A minus C is a multiple of 7, then what will happen? A minus C value may be 0, or A minus C may be 7, or A minus C may be 14. Is there any possibility to get 14? Since A and C are different digits, the difference between the digits, most probably this is 9 minus 0, the largest possibility is 9. There is no chance of getting 14 and more. See, whenever the difference between A and C is 0, if both the digits are same, then only the difference between those numbers is 0. So if both are 1, if both are 2, like that, if both are 9, you will get the difference as 0. Okay, and whenever the difference is 7, whenever the difference is 7, see if the difference between them is like 7 minus 0, 8 minus 1, 9 minus 2. In the same manner, 2 minus 9, 0 minus 7, 1 minus 8. Total here how many chances you have? 9 chances. Okay. See here you have 9 chances, there you have 6 chances. Among these chances, if you select 0, 7, the value of A will become 0. See, A can't be 0 because it's a 6-digit number. So neglect it. After neglecting this, we have 9 chances here to get the difference as 0, and we have 5 chances here to get the difference as 7. So totally there are 14 chances to get the page for AC. So to select A and C we have 14 chances. See, B is not included in this selection. They mentioned that B is an odd number. So you can take any odd number in the place of B. The number of odd digits are 5. So since this is 14 and the chances for B is 5, the total number of counting is 14 into 5 and your answer is 70. So there exist 70 numbers in this format which are divisible by 7 as well as the digit B is odd. Okay, so your answer for the third question is 70. Right? Now, let us see the fourth problem of this RMO 2018. See, the fourth problem is related to the base N system. So if you observe, usually the Olympiad examinations like PRMO, AMTA, like some other competitive examinations, usually they ask a question related to this binary system. Okay, and you are very familiar with the system, and the usual system what we are using is the decimal system. So in the decimal system we will write some number 273 or 2, so we write it like 2 into 10 square plus 7 into 10 plus 3. Okay, we write the regular 3-digit number in this format, right? So if the system is not base 10 or decimal system, if you are using binary system, so the binary system consists with the digits only 0 and 1, then we use only 2. For example, if you have a number 1011 line in the binary system, see we convert it to the usual decimal system by multiplying 1 with 2 cube plus 0 into 2 square plus 1 into 2 power 1 plus 1. Okay, see this number is in base 2 system. To convert this base 2 system number into base 10 system, we use this procedure. Okay, we multiply each digit in that system with the power of the corresponding base. Okay, so in this problem they mentioned that 166 into 56 is equals to 8590 in a certain base system. Okay, see in that base system 168590 all are the digits. Okay, find the sum of all possible values of B and the value of B is greater than or equals to 10, satisfying the equation. Since this is happened in base system B, we need to convert every number into the usual number system format. Since 166 is a number in base B, so we will write that 166 as 1 into B square plus 6 into B plus B into, and thus 56 as 5 into B plus 6, whereas this 8590 as 8 into B cube plus 5 into B square plus 9B plus 0. To calculate the value of B, we just use the normal equations format. So we have here as B square plus 6B plus 6 it is. Okay, 6 when multiplied with 5B plus 6, and that is equals to 8B cube plus 5B square plus 9B. Get everything one side to get the value of B. See, if you look here, B square into 5B is 5B cube. There we have 8B cube. If you send it there, you left with 3B cube. Then coming to square term, B square into 6 is 6B square this side. 6B into 5B, 6 5 is 30B square. 6B square plus 30B square is 36B square. If you send that side, you 5 minus 36 is 31B square. Then coming to the B term, see 6B into 6, 36B, 6 into 5B, 30B. 36 plus 30 is 66B. Okay, and then we have 9b. 66 minus 6 minus 9. See, b square into, that will okay. 6b square is already over. Then coming to 30b square is over. 6b into 6 is 36b. 6 into 5 is 30b. 36 and 30, 66. If you send that side, 9 minus 66. 9 minus 66 is, and then 57b. Okay. Then coming to the constant term. Then coming to the constant term, 6 into 6 is 36. If you send that side, minus 36 is equals to 0. So we have to calculate the value of b. So the value which is satisfied by this equation. Okay, since it's a cubic equation, okay, to calculate the value of b, usually there exist three values for b. Since it's a cubic equation, the product of all these values is product of roots. Okay, product of values of b is like 36 by 3, which is nothing but 12. Since the product of all those values is 12, the factors of 12 is a root for this equation. Since we are searching for the base b system b, that b must be a natural number, and they mentioned that b is greater than 10, so surely b is equals 12 satisfies this equation. So your answer is 12. So this is happened in base 12 system. Okay, how we check? By converting the given calculation into given calculation of base b system to the usual calculation, and then by rearranging you get a cubic equation. From this cubic equation, the product of the all possible values of b is 12. So one of the factor of 12 is the factors of 12 are the roots of this cubic equation. We are searching for a natural number which is greater than 10. So we need to select a factor of 12 which is greater than 12. Okay, so which is 12. So clearly 12 satisfies this equation, and that 12 is your answer. Okay, that ends the fourth problem of RMO 2018. Okay, so these are the first 4 questions of RMO 2018, and again I meet you with some other questions. Okay, do subscribe for the channel. Thank you.